Hey guys, today you're going to do the last page in your Unit 1 packet. Yay, you made it! We're going to talk about different states of matter today, and we describe matter in two terms. So we can describe it as definite and indefinite. Definite means that it does not change, and indefinite means that it can change. So if I said you definitely have a test next week, we're at the end of our unit, we're not going to change our minds on that. That test is definitely happening. Okay, so that's the difference. So one of the important things you need to know for matter is intermolecular forces, which you can abbreviate IMF. So here's the I, here's the M, here's the F. So these are basically the forces that hold everything together. If everything is made of atoms, the IMF is the force between the atoms. Something has to keep those atoms from wandering far apart from each other, and that's what IMF is. The different kinds of matter that we know, you've probably heard of these, we've got solid and liquid and gas types of matter. So we're going to look at the differences between all of those. So I'm going to draw a picture. Solid particles look like this. So notice that they're really tightly packed, they're close together, and even look at the shape of them. Even though that's in a square box like this, the solid isn't taking the shape of that container. It's got its own different shape. And if I took the solid out of that container, it would still have the same shape that it currently does. So, the volume of these particles cannot change. See how they're already really tightly packed? We can't squish them anymore, so we cannot change how much space they take up. When we cannot change something, that is a definite volume. Same thing for the shape. Even if I took the solid out of this container, its shape would not change, which makes it definite. The reason why is because solids have very high IMF or very large IMF, so it's really strong forces holding all of those particles next to each other, and that gives it the definite shape and volume. Liquid particles look like this. So notice that they're still kind of close together, but now the shape of this depends on the shape of the container. So what that means is the volume is still definite. I cannot squish those particles together anymore. They're already really close, and so the space or the volume cannot change. But I could change the shape of that liquid if I took it and I poured it into a container that was very tall and narrow. Then those particles would take a different shape of whatever I put it in. So the shape of a liquid is possible to change, which makes it indefinite. And so they kind of have medium IMF. They're not really as strong or as high as in a solid. Lastly, we have a gas. Those particles are just all over the container. Because there's space between those different particles, I actually could change the volume. I could squish those particles together so they took up less space. That's what condensed air is, when I squish the particles and I change their volume. When you can change something, it is indefinite. I could also change their shape, so that is also indefinite, and it's a similar idea. If I put those gas particles into a different container, they would use that shape. Because those gas particles are so far apart from each other, they have very low, or what we would describe as very weak IMF, and that's why they can be so far apart. Now, all of these particles have energy, and you've probably heard of the two different kinds of energy. There's kinetic and potential. And so just a quick review, kinetic is energy from movement. So kinetic means moving, and potential energy is from its position. The object is just sitting there not doing anything, but it still has some energy in it. And so the law of conservation of energy says energy can be converted from one form to another, but it cannot be destroyed. So I could start off in your hill diagram with kinetic energy as I'm moving up the hill, and then it would switch to potential energy when I get to the top, and then it would convert back to kinetic energy as I move down the hill. That's what the law of conservation of energy is. You can switch back and forth, but you can't ever lose energy. So what we care about is what does that energy look like for our particles. And so I'm going to open the simulation, and you have the link as well that you can do it on your own computer if you want. So here is a container, and I can change the shape of it if I want to. I can make it bigger, smaller, but what I really want to do is I want to put some particles into it. Okay, so all of these little blue dots are particles, and we would call those gas particles because they're far apart, they're floating around their container, they're not really tightly packed together, so this is a gas. Right now, these particles have kinetic energy because they are moving. And so what we want to see is, well, how can I change their energy? So I'm going to add some heat, and you'll notice that the temperature is going up. And what you'll also notice is that changes what the particles do. The more heat we add, the faster and faster those particles move. So the warmer it gets, the faster and faster and faster they go. Because we're changing their movement, we're changing their kinetic energy. Okay? They had so much kinetic energy that they were able to burst out of that container. So let's try the opposite. If I put some of those particles in there, get our gas floating around. And this time, if I remove heat or I make it colder, we're also going to see a change in the particles. So notice the temperature going down, and the particles start to act a little bit differently. They start to go slower and slower and slower. And so they're never going to completely stop. They always have to move, even if it's just a little bit. But they're going to go so very slowly that it's going to almost look like they're not moving at all. So again, if we're changing how they're moving, we're changing their kinetic energy, because kinetic energy is the energy of movement. And so you can play with that simulation. I'm going to go back and we're going to try to put that together into some of these questions. So question number 1 says, when the particles are heated, describe what happened. So when we heated those particles, what happened was they moved faster. They were bouncing around, flying across the walls, bouncing into everything, but they did it fast. Okay? Based on your above answer, which type of energy is changing? Because we changed how they moved, the energy of movement is kinetic energy. So when we changed the temperature, we were changing their kinetic energy. So now if we put that together, when temperature increases, it was their kinetic energy, and because they were going faster, that kinetic energy was increasing. When temperature decreases, we were also changing the kinetic energy because we were changing how they were moving, but they ended up going slower, and so they were decreasing the amount of kinetic energy. So these are the important things that you need to get out of this. Whenever things are moving, that's kinetic energy. Increasing the temperature increases kinetic energy, and decreasing the temperature decreases kinetic energy. Alright, that's it. You're officially done with your first chemistry packet. Good job. Come let us know if you have any questions. Good luck!